So all we've been focusing on for the last, I don't know, a couple of weeks, have been talking about solving equations, right? We're talking about solving things that were equal to this, equal to that. But now we're going to look at a different situation. What if it's greater than this? What if it's less than that? What if it's greater than or equal to? What if it's less than or equal to? That's the type of situations we're going to be talking about today. So, a few things. Interval notation is the first thing we're going to talk about. That is just another way of writing out writing a set of numbers, really. But how to write the answer is going to be in interval notation. We're going to talk about the properties of inequalities. What can we do to them that'll make them keep the relationship or actually negate the relationship? We're going to talk about solving inequalities and solving combined inequalities. Two inequalities combined together. So the first thing is kind of a little review of what we talked about in one of the R sections, just to make sure we're all on board with that. How large is this going to be? Oh, that's too large. So we want to graph these on a number line, and there's a reason why we're doing this. It's going to go and help us when we do the interval notation. So this first one, x is greater than 5. I can't really see it too well, huh? I'll make it larger. Or I'm just going to move it. And we're going to move these. How does that look? That's a little bit better. All right, so if we say x is greater than 5, what side of 5 is that going to be, on the left or the right? The right. And for some reason 5 is missing, so it's going to be over here on the right. And what are we going to put at 5? We either put a parenthesis or a bracket. Parenthesis, we put a parenthesis because it's not equal to 5. Any questions on that? All right, we got x is greater than or equal to negative 5. How are we going to write that one? It's going to be the left or the right of negative 5. It's going to be the right, because it's greater than. It's going to be all of this. And then since it's equal to 5, or it can be equal to 5, what are we going to put at, negative 5? What are we going to put at negative 5? A bracket. Yep. Any questions on those two? Well, we'll skip through the next two because they're kind of similar, except they're less than. So this one's less than 0. So it's going to be to the left of 0. And we're going to put a parenthesis there because it's not equal to. And then x is less than 2. It's going to be the left of 2. And since it can be equal to, we'll put a bracket there. Any questions on those? So let's look at 5 and 6. So we have x. Well, let's read it as it's written, and then we'll talk about how to read it. So we're saying negative 6 is less than x, which is less than 4. The easiest way to read these, instead of reading it left to right, in my opinion, is to read it from the x, from the variable, right? This is saying that x is greater than negative 6 and less than 4. Okay? How are we going to graph that? Anybody know? It's greater than negative 6, so it's to the what of negative 6? To the right. I'm just going to put a little bit there. It's less than 4, so it's on what side of 4? The left. So it's going to be all these numbers in between negative 6 and 4. Now, since it's not equal to those, right, there's no bar under the inequality, we're going to put a parenthesis on both of them. So it's basically any real number between negative 6 and 4, not including negative 6 or 4. Questions on that? Nope. Let's look at 6. So 6, it's saying that x is greater than or equal to -2 and less than or equal to 3. How's that graph going to look? We got -2 here. We got 3 here. It's between those two, so it's going to be that range between those two there. Can it be equal to -2? Yes, so we're going to put bracket. Can it be equal to 3? Yeah, we'll put a bracket. We'll put a bracket there. Got a little too excited. That's not right. Any questions on that? All right, let's talk about 7. That's a good one. So here we got x is greater than -5 and less than or equal to 4. So we know it's going to be between -5 and 4. Let's fill that part out. -5 all the way to 4. On the -5, can it be equal to -5? No, so we're going to put parentheses there. Can it be equal to the 4? Yeah, so we're going to put a bracket there. Okay, so notice these are the 3 different things that can happen here. You can have both of them be parentheses, both of them be brackets, or one is a parenthesis and the other one's a bracket. Okay? There's different names for these. So when you have a interval, that's what we're talking about here. These are intervals, right? That is just parentheses. This is what we call an open interval. On 6, when you have the brackets and it can be equal to those endpoints, anybody have a guess of what that's called? Start spelling it out. The closed interval. Basically, it's because the open interval, it's open-ended, right? You don't really know where it stops. You can keep getting closer and closer to those values, like 4. You can say, well, it's 3.99. But you can say, well, it's 3.99999. And it's 3.99999, right? So it's kind of open-ended. Closed, you know it stops at 3. And then this last one actually has 2 names. You could call it a half open or a half closed interval. It's kind of, you know, is the glass half empty or half closed? I messed up. Half empty or half full? Is the interval half open or half closed? So that is the 3 or just 4 different names you can use to describe these. I always remember this one because I don't know if they still have it in there, because I haven't been in a while. But in the Mu Lab, there was a sign that said this section closed, and one of the math professors wrote brackets around it. That's how I always remember it from his kind of lame joke. But yeah. Any questions on that? Nope. All right, so let's look at 8, because 8's a little tough. If we read it from the x, it says x is less than 7 and x is greater than -1. What's weird about that? Does anybody see anything weird about it?
It's not between the numbers, it's only the other side.
What do you mean?
Like it's not gonna be between the numbers.
It's
gonna go, one's gonna go to the right and one's gonna go to the left.
Well, let's look at what it is. So if we just look at this half right here, well, let's start from the front, right? We just look at this half right here. That's saying x is what? Less than 7, right? So 7's here, so it's over here. It's to the left of 7. And here it's saying x is greater than -1. So it's what? It's from -1 to the right. So it is this interval right here, right? between -1 and 7. But what's kind of funky or what's weird about the way it's written? Because it looks confusing, right? At least it looks confusing to me. Look at the three before it. It was from -6 to 4, from -2 to 3, from -5 to 4. Yeah, we flipped it, right? So if you ever get one like that that's confusing, you write it in increasing order. So it's -1, x is greater than that, and it's less than 7. You can still rewrite this, just like how I was rewriting the equations the other day when I would flip them, because I would say, well, I want the 0 to be on the right-hand side just because it looks nicer. Same situation here. So if you need to rewrite it, you can. Now, what you were saying, Morgan, that is something that could happen, where you end up with something like x is what? So greater than 7 and less than -1. But that can't be true, right? Because you can't be less than -1 and also greater than 7, right? So if you do see one like that, that's just an empty set. There's just nothing in there. So it is possible that you can see something written that way. It's just someone made a mistake. All right, so yeah, I guess we can grab this one out while we're here. So if it's between -1 and 7, that means it's going to be the right of -1 to the left of 7, and we're going to put parentheses on both of those. So that one's an open interval. Any questions on that? So there's a reason why I do this. I don't just do it because I want us to draw graphs. Writing these intervals like this on a graph makes it way easier to write it in interval notation. Okay? So if you have this and you want to write it in interval notation, this is actually the examples I have right here, but we'll just do it here while we're here. The graph tells you exactly how to write it. There's a parenthesis, and then that's at -6, comma, to 4, and what symbol do we have on the 4? A parenthesis. That is that inequality written in interval notation. Parenthesis, -6, comma, 4, parenthesis. For number 6, it's a bracket, -2, comma, 3, and a bracket on the 3. That's it written in interval notation. For number 7, it's a parenthesis, -5, comma, 4, and on the 4 we're going to put a bracket. Now 8, if you look at the inequality, it could be confusing, but if we look at the graph, it's a parenthesis, a 1 to the 7, and a parenthesis. The interval notation always should be written from lowest to highest, left to right. If you wrote parenthesis 7, comma 1, parenthesis, that would be incorrect. Any questions on that? No? So let's back up. Anybody still writing? And we back up and go to these other ones we looked at. How we write those interval notation? Well, you gotta be think about it a little bit. As it's going on and on this way, what value is it heading towards, or what theoretical value is it heading towards? That's heading to positive infinity. So to write that interval notation, we got the parenthesis, that's happening at 5, to infinity, and for infinity, we never put a bracket because it's a value we cannot achieve. We can't be equal to it, so we're just gonna say upper. And what I mean by that is if you say, well, 3 trillion is infinity, I can say, well, what about 3 trillion and 1? We can go for infinity. Let's keep talking about it. Any questions on that? Let's look at 2. If it's greater than or equal to -5, bracket 5, comma, this one's also heading off to the value of infinity. And we still put a parenthesis on the infinity because we cannot achieve it. Let's talk about 3. What is that one heading towards? It's going all the way to the left. Well, this way for y'all. So what value is that going to? Negative infinity. It's the infinity on the other side. And so for that one, the interval notation is going to be parenthesis negative infinity to 0, and we had a parenthesis on our 0. And then number 4, that one's also going to negative infinity on the left there, so it's going to be parenthesis negative infinity to 2, and we can't be equal to 2, so we're going to put a parenthesis. That's basically all the different ways we can do interval notation, except for one situation. Any questions on that? All right, let's talk about that situation. So we did these out of here. So what if we have a number line, and we're going to give you the number line, and I want to write this in an interval notation. So let's say you have this. Notice that it's 2 different intervals, right? We have the left of -2 and the right of 1. So it's 2 separate regions, 2 separate set of numbers. How can we write that? Well, we know that this interval right here is going to be negative infinity to -2, parenthesis. And this, this interval right here is going to be 1 to infinity. How do we combine them together? We're going to do what's called the union of 2 sets, which is just a big U between the 2 sets. I believe my math lab will actually allow you to type the word or, which is the logical meaning of union. It means it's in this set or that set. Or you can just use the union symbol. Either way. We got a chat message. Oh, yep, the U. The other operation is intersection. Do we use intersection in here? No, we don't use it. We don't use intersection at all. But just in case you're curious, the other operation between sets is an upside down U, and that's called an intersection. But I don't want to talk about it too much because we're not going to use it. If you are interested in it, let me know. It's kind of funny though that they were like, well, what are we going to use for union? We'll use the U. What are we going to use for intersection? Just flip it upside down. I mean, it's probably invented before they actually even used the word union. it's probably from Greek times. All right. Any questions on that? All right, so let's see if we can go back. What if we have these interval notation and we want to write it as an inequality? So the first one, it's kind of small for y'all. Just move stuff around by accident, and then we'll make it grow. There we go. For this first one, we got bracket 1, comma 4, parenthesis. How can we write that as an inequality? What's the first thing we got to write? The what? X? Okay. We put our X. What is it bound by on the left? what number is the lowest value it can be? 1. So we'll put a 1. What's the relationship between those? X is greater than 1, but also it can be equal. So we need to put a little bar underneath our inequality. Questions on that part? What is going to be the inequality we use for the 4? X is what? It's less than 4, right? So we'll do less than symbol and 4. Questions on that? Here. All right, let's talk about B. So B is parenthesis 2, comma, infinity, parenthesis. Are we going to write that as an inequality? What's the lower bound? What's the lowest value we could achieve? 2, right? I don't know how I like the word achieve. What's the lowest value it can be? 2. What's the highest value it can be? There's really no bound, right? It's infinity. So how are we going to write that? X is greater than 2. If you want to write it as 2 is less than X, you can write it that way too. Either one of those will work. There's no upper bound on it. I like writing it in terms of the X. Like X is greater than 2. I feel like that's easier to comprehend for me, but I mean everybody's brain is a little bit different, so whatever makes sense for you. Questions on that? All right, C. We got bracket 2, comma 3, bracket. How are we going to write that as an inequality involving X? Well, we can put our X, right? We know it's got an upper and lower bound. We know that it can be equal to them because there's brackets. So let's put the equals. What's the lower bound? 2. What's the upper bound? 3. There you go. Now let's do one last one. D. So it's parenthesis, negative infinity, comma, negative 3, bracket. How are we going to write that?
X is less than 2.
X is less than negative 3, or it could be equal to it. This is a bracket. Yep. Good. So most of the time, you won't be going that direction. You won't be going from interval notation to inequality in this class. I mean, conceptually, you could in some point in life. But it's good to understand the backwards method of doing it as well as the forward, so that way you fully understand the concept. Any question on those? All right, see what's next. All right, bunch of notes. All right, so I already talked about open interval, closed interval, half open, half closed. Got ahead of myself there, but there's notes in the book. Because I think I stole these from the book. They look like the book. All right, so let's talk about some interesting ones. So for any real number a, if you have a squared, we know that's greater than or equal to 0. How do I know that? Let's think about it. When you talk about real numbers, right? Usually we think of that in 3 different scenarios. Right? You can have where a is a positive real number, a is a negative real number, or a is, anybody know? What's not positive and what's not negative? 0, right? So either you think about a is positive, a is negative, a is 0. If a is positive and I square it, I know it's going to be a positive number, right? 2 times 2 is 4. 2 squared is 4. 3 squared, 9, right? It's going to be positive. If a is negative and I square it, if I take negative 2 and square it, what is it going to be? Still going to be positive, right? Because it's going to be a negative times a negative. It's going to become a positive. It's going to result in positive. It doesn't become positive, right? It results in positive. If a is 0 and I square it, what's 0 times 0? Is 0. So no matter what number, what real number a is, a squared is going to always be greater than or equal to 0. If it's positive, it's going to be greater than 0. If it's negative, it's going to be greater than 0. If it's equal to 0, it's going to be equal. Any questions on that? So if you ever get a problem and they say x minus 1 squared, oops, sorry, I messed it up, is greater than or equal to 0, what's your answer going to be? It could be anything here, right? So the answer to this is going to be negative infinity to positive infinity. It could be any real number. If you get a problem that says x, I don't know, minus 3 squared is less than 0. But if I square some real number, it's always going to be greater or equal to 0. So this is going to be no solution. Okay, so that's where that's useful. That's the method. Any questions on that? No? All right. We're actually going to do problems like this later on, but it won't always be 0. All right, this next one. It seems elementary, but I mean, it's important because we need to know this in order to solve these inequalities. If A is less than B, I can add the same real number to both sides and it retains that relationship. So if I add C to both sides, A plus C is still going to be less than B plus C. And if it started out as A is greater than B, I can add C to both sides again. It still retains that relationship. A plus C is still going to be greater than B plus C. If we didn't know that, then we really couldn't do much. And the same thing is true for subtraction, right? If I subtract C from both sides, it retains that relationship as well. Any questions on that? So that means I can add and subtract to both sides of my inequality, and the inequality will still be true. Multiplication. I can multiply both sides of an inequality, and the inequality will remain true, but only if the value I multiply both sides by is positive. It can't be 0, and it can't be negative. So I can multiply both sides of the equation by a 3, that's fine. By a 1, that's fine. By a half, that's fine. If the number I multiply both sides is negative, it negates the inequality. Okay? So instead of it being A is less than B, now it's AC is greater than BC. So if you multiply both sides of your inequality by a negative number, your inequality is going to flip. Any questions on that? Realistically, what happened? Let's try that again. Realistically, what is happening is that it's negating the inequality. And the same thing if you start off with greater than. Positive number, it's fine. Negative number, you gotta switch that inequality. Questions on that? That's where most people mess up. They forget to switch the inequality. Okay. We'll do some practice, you'll see. Reciprocal properties. If A is greater than 0, Then the reciprocal of a, which is 1 over a, is also going to be greater than 0. If 1 over a is greater than 0, then a is greater than 0. And the same thing is true if a is less than 0, then 1 over a is going to be less than 0. If 1 over a is less than 0, then a is less than 0. Interesting thing about fractions, though, we can talk about. If you have a over b is greater than 0, what can we figure out from that? What makes a fraction positive? There's two situations, two scenarios. Anybody know?
We got a negative in the denominator.
Okay, all right, so let's look at that one. So I'm gonna number these because there's 2, right? So you're saying that b is negative, right? So b is negative, so b is less than 0. What does a need to be then?
Less than 0.
Yes, a would also need to be less than 0. I had to think about it because the negative divided by a negative is what? Positive. So if my numerator and my denominator are negative, then that fraction is going to be positive. The other way that could happen is what? Yeah, both of them are positive, then the fraction is going to be positive. So if you get a problem like that, I think I drew one in the notes actually. You got to look at both scenarios that can happen. So that's one that people get confused on. And it's always nice to talk about it because it makes you think. All right, what else can we do? Procedures that leave the inequality symbol unchanged, so this retains the relationship. You can simplify either side, which that makes sense. You can subtract the same expression from both sides. Yeah, we talked about that. And you can multiply or divide both sides of the inequality by the same positive expression. So if you're multiplying or dividing and it's positive, it remains the same. If you switch it around, so instead of writing 3 is less than x, and you write it as x is greater than 3, that's fine, but you are switching the inequality. And if you multiply or divide by a negative number, negative expression is what they say, then the relationship will switch as well. So if you have negative 2x is greater than 6, and you divide both sides by negative 2 to solve it, you're going to end up with x is less than negative 3. It's going to swap the sign. I never thought about that. So if you think about it, like for inequalities, you really don't want to multiply or divide by x because you don't know if x is negative or positive. I never really thought about that. Again, you wouldn't know what to do. So that's something to think about. I don't think you'll see anything like that. All right, so let's look at, I haven't checked the time in a while. Okay. Let's look at some examples. So we have this inequality, 4x plus 7 is greater than or equal to 2x minus 3. I'm going to rewrite it so I can work with it. First step, make sure you write it down correctly. So the same situation applies for these as we did for the linear equations. You want to get all your x's on one side, all your variables on one side, everything without a variable on the other, and then you want to isolate the variable. Same exact process. The only thing that's different is those properties we learned about inequalities. If you multiply or divide by a negative, the inequality is going to switch. It's really the only thing. So to solve this one, what do you think we should do first? Got an x term, so a variable term on both sides. We also have a constant on both sides, so we need to move stuff around. All right, subtract 2x. That'll work. I mean, there's weren't really too many wrong answers. There's like 4 things you could have did. So let's see, we get 2x plus 7. Now, we just subtracted a value, right? So it's going to stay greater than or equal to. And then it's just going to be what? Negative 3? Mainly on that side. The right-hand side. What do you want to do next? We're going to subtract 7 from both sides. That'll get our x terms all alone. So that'll be 2x is greater than or equal to negative 10. Notice that it's still greater than or equal to. We just subtracted 7 from both sides. And lastly, how are we going to solve this? How are we going to isolate that x? We're going to divide both sides by 2. We're dividing by a positive number. So the inequality does not switch. So we just end up with x is greater than or equal to negative 5. Any questions on that? Now, how do we write that in interval notation? If you struggle at all, just take the time to do this. Say, okay, negative 5 right there. If it's greater than or equal to negative 5, which side of negative 5 is it on?
Right.
They're right. Keeps going, right? There's no bound here. What symbol are we going to put on the negative 5?
Bracket.
A bracket, because it can be equal to. And so now, reading off that graph, we know that the interval notation is going to be bracket, negative 5, comma what? Infinity. Always put a parenthesis on the infinite. So that is going to be. So you don't have to draw any type of beautiful number line or anything. Just something simple gets the job done. But it really helps you to visualize it. And I would recommend, if you struggle at all, going from inequalities to interval notation. Quick number line will get you there. Any questions on that? Arrow. Here what we have is a combined inequality. You got negative 5 is less than 3x minus 2, which is less than 1. That means that 3x minus 2 is between negative 5 and 1. So there's a problem with talking about these because we no longer have a left-hand side and a right-hand side. So I just call them like parts. That's usually how I'll say it. Sometimes I'll slip up there. So, but the same process, you want to get your x's or your variable. I say x every time, but you want to get your variable alone. So if we look at this one, that left part is a constant. The middle part has an x term and a constant, and the right part there has a constant only. So what do y'all think we can do? I want to get a 3x by itself. What do I do? We're going to add 2. Whatever we do here, we have to do to all the parts. Yep. So we'll end up with negative 3 is less than 3x, which is less than 3. So basically all we did was shift the whole thing 2 units. Well, which way for y'all? Get that way. And what do we want to do next? Isolate the x, so we're going to divide all our parts by 3. We're dividing by a positive, so the inequalities won't change. And so what we're left with is negative 1 less than x is less than 1. How do we write that? in interval notation. Oh, always go back to the handy dandy number line. We got -1 here. We got 1 here. We know it's greater than -1, so the right of -1, less than 1, to the left of 1. And it's not equal to them, so we're going to put parentheses. And so my interval notation would be what?
Parentheses, -1, comma, 1.
Yep, there you go. Any questions on that? I always forget y'all see the cursor, so I try to keep it up. Whoa, that's not the one I wanted. Well, let's go do this then. Let's go back to this first one. And I shouldn't have erased the answer because I wanted to show you that we get the same answer, but it was what? -5 to infinity, I think. Oh well, we'll figure it out. But let's say that when you're solving this one, instead of subtracting the 2x, you say, well, I'm going to subtract 4x from both sides. And so what we end up with is 7 is greater than or equal to -2x minus 3. And so we're going to add 3 now, right? And we're going to get 10 is greater than or equal to -2x. Now to solve this one, to isolate the x, what are we going to have to do? Divide by -2. Now when we divide by that -2, the sign is going to switch. So it's going to be 10 divided by -2, which is -5. Instead of being greater than or equal to, it's going to be less than or equal to x. And so now if we write it from the perspective of the x, it's what? X is greater than or equal to -5. So you see how we got the same answer? I wanted to show you one where the sign switches. Any questions on that? It can also happen on a combined one. If you multiply and divide both sides by negative on a combined inequality, both signs are gonna swap over. Okay. All right. Do we have time to do that one? I think we have time to do one. So somehow the mouse pad got stuck there. Okay. Let's start with this one. We have 4x minus 1 raised to the -1 power is greater than 0. Now, when I have 4x minus 1 raised to the -1, what's another way I could write that? What do you do with a negative exponent to make it positive? We're going to take the 4x minus 1, bring it to the other side of the fraction bar. So this is the same thing as saying 1 over 4x minus 1 is greater than 0. Yep, it's the reciprocal. Now let's think about it. Remember, there were two situations that we had to think about this. If it's greater than 0, that means either the numerator and the denominator are both positive, or the numerator and denominator are both negative. They have to be the same sign for it to be greater than 0, right? But we get restricted here because 1 is already positive. So if the numerator is positive, what do we know has to be true about the denominator? It needs to be positive as well. So we could take this and just say, well, 4x minus 1 has to be greater than 0. And now we just gotta solve that up. Add 1 to both sides. 4x is gonna be greater than 1. And then we're gonna divide by 4. And so x is gonna be greater than 1/4. Which means it'll be what? 1/4 to infinity.